In this video, we will discuss the process lifecycle, including its initiation, stages, and types of processes. In Linux, a process is simply a program that's running. When you open a text editor or run a command in the terminal, that program is turned into a process by the system. Think of a process as the live version of a program, something that uses the CPU and memory and does real work. Linux is great at multitasking. It can run multiple processes at a time. However, behind the scenes, each process goes through a life cycle, which means it has different stages from the moment it starts to the moment it ends. Let's understand how the process life cycle begins. It starts with something called a fork. Fork is a system call that creates a new process by copying an existing one. Usually, a parent process creates a child process. When you open the terminal and type a command, the shell, which is also a process, forks a new child process to run your command. After the fork, the system may use another system call, exec. This replaces the memory of the child process with the actual program you asked it to run. So, first it makes a copy, then it loads your new task into that copy. At this point, the process is now running. Let's walk through the stages in the process lifecycle. The first stage is new, created. This is when the process is born. It's just been created with fork, but hasn't started doing anything yet. The next stage is running. The process is now executing on the CPU, performing its job. Or it might be ready and waiting for its turn on the CPU. Waiting, or sleeping, is the next stage. Sometimes, a process needs to pause because it is waiting for data from a file or the network. When the process is waiting but can be woken up by something like keyboard input, that's called interruptible sleep. If it's waiting for something that can't be interrupted, like a disk operation, it's called uninterruptible sleep. Then comes the stop stage. A process can be paused, usually by a user pressing Ctrl+C. It's still in memory, but it doesn't do anything until someone tells it to continue. The final stage is terminated, dead. This is where the process ends and exits. But here's where things get interesting. Even after the process finishes, Linux needs to clean up. Sometimes, this cleanup is delayed or forgotten. That's when we get special types of processes. What are the different types of processes? Let's go through them with examples. Running process. This one is simple. If the process is on the CPU or waiting for its turn, it's considered running. You can identify the active processes by using the top or PS commands. Sleeping process is the next type. This process is currently inactive but is waiting for an event, such as a file to be read or a network response to arrive. Most Linux processes take a lot of time here because they're often waiting for external resources. Also, we have stop process. This is when a user pauses a process. It's not dead, just frozen. You can resume it later using commands like FG or BG. Another type is a zombie process. Yes, zombies exist on Linux too. A zombie process is one that has finished running, but its parent hasn't checked it yet. Linux keeps it in the process table to store the exit status. Once the parent reads that exit status, the zombie disappears. If the parent never does, it stays there as a zombie. Orphan process is the last type. This happens when a parent dies before their child. Now, the child is left without a parent. However, Linux is smart because it allows the init process, PID1 or systemd, to adopt the orphan, ensuring it doesn't get lost. These processes usually run without any issues. Now, let's explore why you should care about the process lifecycle and types. If you're learning Linux or studying something like RHCSA, Red Hat Certified System Administrator, this is important because real servers deal with processes all the time. Understanding how they behave helps you troubleshoot slow systems, kill frozen or runaway processes, monitor performance more effectively, and avoid problems like memory leaks caused by zombies. System administrators often rely on tools like PS, top, and kill to work with processes. However, before using those tools, you need to understand the type of process you're looking at and its current state. Processes in Linux are like little workers that perform tasks. Some are awake and running. Some are waiting for something to happen. A few might get stuck or go missing. Understanding their life cycle helps you manage the system better and solve problems